var duration, because yeah, just a small example. Then we have an init, and you already know that. We then just say self duration equals duration. Now inheritance, we have a class song that inherits from library item, and we have a class movie that inherits from library item. And we can just, I don't know, no, that's fine. Let's leave it like that. Then we have a list of library items where we just define the type like this. And we just throw in a song here with the duration of, I don't know, 10. Let's just copy this. So we have a few songs in here. Then let's do the same for movies.
I have a question.
Sure, go ahead.
How often do you use classes for the structs? Because I've read that you should always use structs because they are immutable.
Yes.
Because they're value types compared to classes which are reference types.
Yes, so that's a very good question. So what you've read, I would agree to. Always start out using structs. Because of the immutability, you're way safer there. Also, you've heard with memory cycles that classes can be quite dangerous there. So usually you will start out with structs, but in this case, we are using inheritance, and structs do not have that capability. So if you, for example, need like a typical object-oriented inheritance tree that just models some data, then you will need to fall back to classes because you can't model that with structs.
Okay, thanks. Because most people always suggest also not to really use inheritance, but composition.
Composition, yes.
Yeah,
yeah, exactly. Composition over inheritance. Yeah, that's one of the Swift rules. Yeah, also plays into protocols and so on, that you can define capabilities for certain structs. So I used classes in this example to show you the typecasting, because that's also not something you can do with structs, because obviously the type is defined by runtime. It cannot change because there is no inheritance. But usually you will work with structs and protocols as far as possible to get rid of the classes. But there are still some use cases where you will need to use classes. Does that somehow answer your question?
Yep.
Okay, awesome. Also, maybe just to throw it in now already, because the concept of a struct does not exist in Objective-C, sometimes when you talk to older APIs that come from the Objective-C world, you will need to work with classes because the APIs are not rewritten. So this is kind of an issue with the interopt between Swift and Objective-C. But we'll see that in the UIKit slides then, a bit more detailed. Okay, then let's iterate over the list. And let's do our check. We can just write here our switch, just say item, or actually we want to switch the item, yes. And we can then just say is song, print song, or case is movie, print movie. And this is really annoying. Okay, So we also need to add our default case here. We'll just write unknown. Then if we run this, we should see hopefully 4 songs and 1 movie. And if we then want, but if we also want to use this, we can then, for example, just iterate over it. But instead of switching, we can say if item, so if let song equals item as song, then we can also print song, and same goes for the movie. So else, you can also do else if let, so you can do this like multiple times. Else if let movie is equals item as movie, and then you can print movie. So if we run this now, the output should be exactly the same, and it is. And now, just to show you that you normally should not use force casting, because it is pretty much the same as force unwrapping, sorry. So if you say let song, let movie, because we're totally sure that the first item in our collection is a movie, then you can say list, but like we do the array access, first item in the array as song, movie, sorry. And then we can see that it actually, yes, actually crashed. Abort called, which means, yeah, this is like a runtime error. If you use the optional cast, then nothing will happen. It will just be null and the app will continue running. So it's the same as with any optional, and this casting will just leave. Let me just show you, because I always like to check the type here. If we just print the type here and comment this out so not to spam anything, you can see that it's actually an optional movie. And if we say force unwrap as song, because in this case it is a song, then the type is song. And try to use optional downcasts rather than force casts. Yes, any questions to that?
Yeah. When do you need these forecasts?
The force casting.
Yeah.
So this one.
Yeah.
Usually you don't. So I would strongly recommend you to not use them, but it's possible to use them. So.
Okay, but it doesn't really make sense to use this. Or in our class, it doesn't really make sense to use this.
I would strongly recommend you to not use it, and I would probably, if you do this in an hand-in, I would probably mention that you shouldn't do that, because like the issue with force casting, the same with force unwrapping, is always, it says if you are totally sure that it's there or that it's the type, you can do it, but during runtime things might change, and I don't know, if you can't guarantee the order, maybe of network objects or something like that, then you should not use it. So I would say in general, don't use it. Always do proper unwrapping with if and guardlet, and make sure that your objects are really there. Because in the worst case, if your assumption is wrong, the app will crash and the user will have a bad experience. And that's definitely not what we want to do.
Okay.
So, and why we mentioned that this exists, there is this thing of automatic, what's the proper wording for this? Sometimes Xcode will recommend you auto-completion for certain changes that you do. And Xcode likes to use force unwraps in those recommendations. And yeah, don't trust those. So you should be aware what the Rufzeichen, the exclamation mark, does. And that's why we mention it in the course. So you should be aware that this can crash the app. If you see it, that you are careful. Does that make sense for you, or should I try a different approach?
No, it makes sense. I only wonder because it used to have an advantage because it exists. So, but
it's shorter and it's less overhead.
Okay, that's the advantage. Okay, no, then
yeah. Should have led with that. I'm sorry, but it's a good question. So. Okay, then the next slide is nested types. Okay, so here's a small example of a card game, and in here we have a struct just defined as card, and in there we have so-called nested types. Yeah, so you can have nested types in Swift, so you can have a struct card, you can have inside that struct, you can have another struct that, I don't know, don't have a good name, but it can go quite deep. And what this can be used for is, for example, to properly namespace types. So if you look at this example here, we have the type card, and card is a struct that just has a rank that's defined in here, and it has a suite that's defined in here. And as this is a struct, we don't need an initializer, but it will be generated for us. And we can just initialize the card with a rank and a type, so hearts, diamonds, clubs, spades. So why do we need those nested types? In the end, this allows you to namespace stuff. So if this would not work, you would probably have a type outside of the struct named card suite or card rank, which would pollute the global namespace and yeah, create longer names for you and so on. So this is just something that you can use for your own type structure to just make it more clear for yourself and also for the readers of your code then how those types relate to each other. There's not much magic behind that, but it's just very helpful for model creation and yeah, like this example to visualize or structure a card game. Yeah. Are there any questions to this? Okay. Then we are at error handling. So in Java, you're probably familiar with try-catch blocks. You probably did that in the course, didn't you? Or not?
I think like last week or something, or before 2 weeks ago.
Oh, the course is also still running.
Yeah.
Okay. Okay, good to know. So that it's still fresh. No, we'll go over it again. So in the end, it's like also Swift has this capability of throwing errors, like also Java, like for an example, an IO exception or custom exceptions that you can create on your own. And it's there to respond and recover from, so the handling is there to respond and recover from error conditions. Yeah, so Swift supports, like I mentioned it already, throwing, catching, propagating, manipulating errors at runtime. Yeah, optionals, like in comparison, if you think about returning null or throwing an error, the error usually contains more information than just returning null. So there are multiple. Maybe you have a method that can fail on multiple occasions, and for the caller of the method, it might make sense to get more information on why the calling or the processing of some data actually failed. So it might be a processing issue, it might be a network issue, it might be an I/O issue. I don't know, you name it. And yeah, so this can be used for that use case. And yeah, functions and method that can't guarantee to always execute and produce a result are called throwing functions. Yeah, there's an example also here. While reading and processing a file on disk, a file might not exist, read permission might be missing, format might be wrong. And for that, you can have multiple or different errors that might be thrown, as you can see on the right side. You will usually visualize errors as an enum that conforms to the error type. And you don't actually need to do anything additional with the enum. You just have an enum, in this case, maybe vending machine error that conforms to the error protocol. And then you define your potential errors that might happen when you interact with a vending machine. How is this used? So there are methods that can throw errors and methods that cannot throw errors. So it's been some time since I did Java, but if I remember correctly, I think everything can throw in the end, and you can potentially catch everything. In Swift, a method needs to explicitly define that it throws. So, like as you can see here, this is a method that can throw errors. It just defines this is defined by the throws keyword before defining the return type. So this method just throws a out of stock error, and this method cannot throw because the keyword is missing. And if you try to do that, the compiler will actually tell you, hey, this method cannot throw, so please change that.
In Java, it's the same thing.
Okay, thank you. I wasn't fully sure anymore. It's been a few years. Okay, good to know. Objective-C is actually the better example for this. There you can throw exceptions can be caused from any place, and you can catch everything. But thanks for correcting. Yeah, so using a throw statement. So for example, we have this select item method on our vending machine, and we switch over the item. It's just an index in this case. Sorry. And if we have index 0, we return Coke, 1 beer, 2 water, and if something else is put in, we can throw an error. And as you see, when we throw something, we don't actually have to return anything, because this. So for it tells the compiler that this is an error path and a return value is not needed here. So usually if you have a default case that's empty and you also don't return anything afterwards, you will get a compiler error because every code path needs to return something, not for throwing methods. So if you throw something, you don't need to return a fallback string or something like that, but just throw. Okay, then we have catching and handling errors. So throwing methods can be called using the try keyword. So imagine you want to call the select item method. You would wrap this in a do block, and in there you would call try select item and any other statements you might want to do in that do block. And afterwards you can catch an error and do the error handling. Yeah, that's pretty much it for error handling. We can have a quick look how this works. Let's just remove this. We just have our vending machine functions. And for the sake of it, no, come on. we want to throw here and return a string. And let's say if index equals 1, we return water, and otherwise we just throw. But obviously we need to define our vending machine error enum. And in here we can just say out of stock. And then we just say vending machine error dot out of stock. So this already works. And now if we want to call this, we can just say do. So we can just say do try select item at index 0, and we catch here, and then here we print the error. So as you can see, we don't actually explicitly need to catch the error here. I mean, we do catch the error here, but we don't need to define like the error variable, but it will be available for us anyways automatically. And if we run this now, we can see that it prints out of stock. If we do, let's just say like that, and we try to select the first item, we will return water. And that's pretty much the whole magic behind error handling in Swift. Are there any questions to this?
Yes, I have a question.
Yes.
On the first slide, I believe that there was something required double. What exactly does that mean?
Sure. You talked about enums, I think. If we head a bit back, we can take a look again. And this required would be an associated value. So for an enum, let me go back here and we can quickly go over it again. It's not a big deal. We can have in here again. For example, we can pass here the product that's actually out of stock. So then obviously this would not compile because, how to explain this? So enum cases can have values passed with them as this is called an associated value. This can be named or not named. And this can, for example, help. In this case, we would use it to make the error code or the error message more descriptive. Because in this case, we could then say, we can add here the product, and we can say, I don't know, index. And then if we run this again, oh yeah, obviously this needs to change. It would return something different. So the enum actually can have multiple other types associated with it to contain more information about the case.
Okay, that makes sense.
Okay. Yeah, we will see this in use quite often because it's a very, very cool feature actually. Yeah, but in the end, you can just use it to make your enum case more expressive. Like we did it now to actually communicate that a certain product is out of stock and not only like we just like if we just do it like this. If we are the caller of the API and we get this error, then we know, okay, what product is actually out of stock. But if we do it like that, we have the info, okay, in this case, I don't know, cola is out of stock or beer is out of stock. And this can be used in multiple different ways as well. Is that clear?
Yeah, clear, thank you.
Awesome. Okay. Any other questions? Okay. Then, yes, then we have another interesting thing regarding error handling. So again, exclamation mark. And to start again here, this is something that you can use, but you usually shouldn't. It's just sometimes that, oh, bad start again in describing. The thing with try exclamation mark is that it's just shorter. And if you are 100% sure that your method will not throw with the parameters you pass in, it might be okay, but usually you will want to call it, and I don't see that here. Sorry, we can go here. So instead of doing this with the do and catch, you could also say try, select item with index 0, and if this throws, what will it probably do? It will crash the app. To work around this, if there might be use cases where you don't care if it throws, but you also don't want to crash the app, you can use this. There's also for a huge number of operators, there's ones with exclamation marks and ones with question marks. And for nearly all cases, always use the question mark one. And again, if we say print type of, what will this probably be? Can anyone tell me?
Optional.
Yes, very correct. This again is an optional string. If we use the force, it's not optional, but it can crash the app. So prefer this, the question mark. And yeah, if you do not require catching any errors, so I don't know, let's say we press a button on our vending machine and we don't actually care if we get something to drink, which sounds a bit odd, but who knows? So you just press and you don't actually care if it's out of stock. You can use the question mark. You don't catch an error, and you will be rewarded with an optional drink. Then there's another pretty interesting block that's used for cleanup mainly. It's called defer. And the interesting thing with defer is that no matter where you place this in your function, it will always be called as the last step before the scope exits. So in this example, we process a file, and during the processing of the file, we can have multiple errors that might happen. So we first need to check if it exists. If we are sure it exists, we will open it. So this opens some kind of I/O processing. And if you have done this in Java, you need to also make sure that if you open an I/O stream, you also need to close it again. And that's a pretty good example for defer. So no matter what happens in that function, another early exit, some error, a try catch that fails, so you end up in the catch block, or you have multiple catch blocks, defer will always be called last. So you could actually place this at the top of the file, and it would still be called at the bottom. This is mainly there if you have like multiple catch blocks and you want to reduce code duplication. So you don't want to call close in 15 places, but you just want to have it once, and you want a guarantee that it is executed before the method exits. Yeah, we can have a look at that in code actually. So we will have just a function here. And then here we just say defer. And this just says, Adam, I'm executed last. And then here we can do like we can just print 49 numbers. And if we run this, we will see a lot of output. Or we won't, because I didn't call the method. So now we should see a lot of output. And the defer block is executed last. Any questions on that?
Does the defer execute always, like in some languages, the finally part, try catch finally, and even if an error happens, finally always executes?
Mm-hmm. So defer always executes. So in this example, maybe that's better here. So if you exit here, defer is not called. It's only called once we set it up. But then if we exit at any point further down below here, it's always called. Does this somehow answer your question?
Yeah, I think it's like finally in other languages.
It's very similar, yeah. But you're not limited to error handling with defer. So to be fully honest, in my day-to-day work, I have very rarely the use case where I need to use a defer without error handling. So for example, if we need to write to some file, then we use a defer. But in theory, you can use this in any method you want. You don't need to have try caches. The method doesn't need to throw. You can define this for every method you want. You can use it for cleanup actions. So yeah, but it would also be available to use this as a finally in, or a finally for the error handling. Okay, then we're nearing the end of the Swift slide set. There's one more pretty important point. Did you already talk about concurrency in Java? Or multi-threading?
No.
Okay.
Don't think we have.
Okay. Then let's hope I can explain this properly. I'll do my best. No. In the end, it should be understandable, hopefully. So concurrency pretty much means that, so usually when you run your application code, let's imagine you have an app that displays some stuff to the user, like just use a to-do list as an example. If you don't use concurrency, all the work will be done on the main thread. What is the main thread? The main thread is the thing that also the user interacts with and that all your code happens on. So all the executions, if you have something that takes longer, like for example, imagine you have a huge to-do list in some database and you fetch that without concurrency, so without concurrent operations, this would block the user from interacting with the app. And that's why we can use multiple threads. In Swift, it's not really threads, but we'll get to that. But in the end, it allows you, instead of doing work in a straight line and just put one block after the other, to work on blocks concurrently or at the same time. So you can say, okay, database stuff happens on this, thread, it's called, or dispatch group in Swift, and on the other on the main thread, you just let the user interact with your user interface without interrupting them or anything. So that's the main use case for multi-threading or concurrency in the Swift and iOS universe. And also maybe an additional example would be networking. So if you do a network request, which literally all apps do, or at least a very big portion of them, you don't want to wait for the request to finish until you allow the user to do stuff with the app again. So this is done on a different thread, and the user can actually interact with the app on the main thread again. Yeah. So in Java, you will probably hear about this then in the next few weeks as well. There's this concept of threads where you would create threads directly, but this is not the case in Swift, which in my opinion makes it a bit easier to understand what's actually happening. So yeah, this is the model that Apple or the Swift Foundation gives you. Should be a bit simpler and more efficient. And in this case, it's not done with the concept of threads. So you will not create any threads in Swift, but you will work with queues instead. And like I mentioned already, you will not, if you use queues, you will not line up one after the other on one queue, but you will have multiple queues that work on different stuff at the same time. So the overall performance still of the app still stays very fluid and awesome to the user. Okay. So queues. What are queues? In the end, we have two types of queues, or we have multiple types of queues, but there is one that is very important, and then there's the other type that is also important, but maybe less for you in the beginning. Like I mentioned, there's the main queue, and the thing with the main queue is that all user interface activity must occur on this queue and this queue only. So if you ever happen to do any network request, the system will actually use a different queue for you to wait for the request to finish. But if you rely on this request to update your user interface, you need to get back on the main queue before updating your I don't know, a table or to-do list or whatever. So also written here, and which is also pretty important, is that all non-UI activity that is time-consuming must not occur in that queue. So the user interface, which happens on the main queue, stays responsive. So like I said, the example with the database access, you would usually always put that in a different queue to not block the user from interacting with the app, because a laggy app experience is not really the best. And yeah, the main queue is a serial queue. What does this mean? It executes one block after the other and not next to each other. So you can have concurrent queues as well, which then again allow execution in parallel. But that's not that important for now. So other queues, iOS will mainly create them for you if you need them. And you can create your own, but it's usually not necessary. So usually you would do something like that. So imagine you do a network request. After the network request, you would go back to the main queue by dispatching it with this method and the block that is provided. UIKit, or actually not UIKit, but the run loop, we will get to what the run loop is a bit later, will then take this block and on the next iteration will put this block into the serial queue and execute your update on the view. So it's a bit of a background information, but just know that when you work on a background queue and you want to update your UI or user interface, always go back to the main queue first and then do any necessary user interface updates. It might be something as simple as updating a text on a label, but be careful, this can lead to unexpected behavior, and I think there's even by now an assertion by Apple that it just crashes your app if you do that from a background thread. Exactly. So if you have background work to do, let's use the database example again. You would want to put that on the global queue or on any other queue. You can define then the so-called quality of service, which means pretty much the priority of the queue. So there's multiple qualities of services. Quality of service, there's user interactive, so it will be scheduled rather fast and it has a higher priority. There's user initiated, utility, and background. So if you just do some stuff that might not be affecting the user right away, you can, for example, use the background. So I don't know, maybe you want to prefetch images that are used in the app. You can dispatch that by using background or utility, because it might not affect the user directly. Okay, this might be a bit much now because you didn't talk about concurrency yet. Do you have any questions right away? Okay. I'd love to show you this then in Xcode, because in the playground it's not working that well. If I forget to do this, please somebody remind me. I just want to show you what it means to block the main thread, so the user can't interact with the system anymore. So I just want to show you that. Yeah. And usually you will use .async, so it will not block any other execution on that queue. So in theory, there's also like the chance to use sync here. All the queues also provide async and sync, but it's not necessarily needed to use this right away. And yeah, just use async for now. Sync is how to explain this. Yeah, I've read a pretty good example on that. Sync versus async. Imagine you're working in a restaurant as a waiter maybe, and you accept orders from guests and you get them to the kitchen. And if you use async, so imagine you, this is like a metaphor, obviously. Every time you get an order, you walk back to the kitchen, you give them the order, and they do a background task by preparing the order. If you use async in your queue, you can go back to different tables and take their orders and also hand out other orders. So you don't wait for that one order to be completed. If you use sync, you get one order, you go back to the kitchen and you wait. Then you get the order, then you go back to the table. So async versus sync, in the end, it's just with async, other things can happen in the meantime, and with sync, only one thing can happen. And sync you will usually use. Yeah, that's also a bit of a bad example. You can usually use this for, like if you really have a thing that should not be accessed multiple times, or just one after the other, you can use sync. Otherwise, async makes more sense. I hope this somehow is understandable.
I have a question.
Sure, go ahead.
That would just mean, using sync would mean you would still use it. You would still run the code in serial, wouldn't you? But just using two different queues. So
Yes.
is the only benefit that the main can still handle, I don't know, UI tasks or something?
Yeah, so that's correct. If you have like, how to phrase this? First of all, you're right. Yes, if you use sync, the access will be serial. And that's also one of the bigger use cases. If you didn't talk about multi-threading yet, not all of you will notice, but there sometimes are properties that are not thread safe. So you cannot interact async like on multiple occasions with them. So you cannot read and write them at the same time. For that, you would, for example, use a sync in order that the access on the variable happens one after the other. And that's pretty much what synced queues are for. You execute a block of code, and then the next block of code is executed, and then the next, and then the next. And while you do the one block, the whole queue is blocked. So it's, like Andreas said, it's serial and one after the other. And if you do async, you can do multiple other things at the same time as well, and it will not be blocked.
So, for example, when I have two different code parts and they both want to access the same variable, for example, I would use sync to just to make it safe.
Yes, exactly.
Okay. Yeah, that
so
makes sense.
you can have I will just reuse your example. You can have a property, maybe, I don't know, just a screen title, for example, on some screen that you have, and you have two queues that are async and access that. And in order to make this more consistent, you could have a synchronized queue that manages the access on that property. So your two queues are actually then the access on this property is synchronized. Yes. This is more of a already pretty deep example, and you will probably not run into this very early, but it's still important that you know the concept of dispatch queues, because once you get into your projects and so on, you will need them. Okay, and just to show you a quick example of a dispatch queue, let's just remove this. So in here, I have a dispatch queue, and this dispatch queue gets a block like a closure that we already talked about last time. And in this case, I use a different initializer, or not initializer, but a different method signature. So I can say I want this code block to be executed 5 seconds after now. In this case, you probably already saw it in the output. It will print start, it will print stop, and then it will print executed after 5 seconds. If we now say dispatch queue.main.sync and print again something, we run this. Oh, stupid, you cannot do that. I'm really glad once we don't use. Yeah. Just use sync. Let's move this over here. No, come on. Oh, neat. I really like the autocomplete for playgrounds. I'm missing the parentheses. So as you can see, this prints immediately, and yeah, and this main async after then prints like 5 seconds later because of the dispatch async after. Okay. So that's it for the second slide set. We're already an hour in now. Maybe let's have a quick look at the exercises before we head into the next slide set, or before we do a quick break, I think. The first assignment until next week. So it's just, so you should implement the custom integer. This class should conform to the equatable protocol. So if you have a class, you need to implement this equatable protocol on your own by using the equals operator. And you should also use operator overloading to allow addition and minus, and try it out by having 2 objects and by adding and subtracting 2 objects. So you can do this via operator overloading. And then you should look into the custom string convertible protocol. You can just type that into Google and you will find the documentation on that. And just think about some way to make the string output beautiful. There's no real, no special way that you should do it. Just think about a way to make it nice. And the second task would be to create a function that encrypts a given message. So there's this dictionary that you can use, and you can just use this as a cipher. I think this is just a Caesar cipher, so it will just substitute. So you should just substitute, like A will be substituted with B, B will substitute it with C. So it's just a shift, and you can use this dictionary to do this. And just write a a function or a method that does this for you, and try a few use cases that your encryption actually works. Yes. Any questions for that right away? You can obviously still ping us on Teams, but.
Does try it out mean there should be test cases in the program? Or?
As we're still using playgrounds, no. Just call it a few times with different inputs. So there's no specific input that we provided now to test this on, but just try it out a few times and make sure that it really works, but no test cases yet.
Okay, perfect.
Custom integer is just a class with integer property, or?
I don't want to spoil too much, but you're in the right direction, yes.
Okay.
Okay. Then, if there are no other questions right now, if some pop up, feel free to message us or send us an email. You will also have time today still, but So we're already pretty much a bit over an hour in, and my voice needs a bit of a break. Let's continue at 3:05. Okay.
All right.
Good. Then see you in 10 minutes. So let's dive into Xcode. I've talked about Xcode already a bit in the very first slide deck, like just very basic that we will use it. And now there's a bit of a deeper dive into the development environment and also the simulators and so on, just so you have an overview of what capabilities there are and what you can do, what you maybe can't do. Yeah, let's have a look. So, quick agenda, Xcode, simulators, and also dependency management. For those who don't know what dependency management is, we will get to that, and I will explain it again when we get there. Okay, Xcode. First prerequisites. I hope you all already downloaded Xcode. And it would be awesome. That's not something you need to do now. You will probably need it then next week. Yes, that you create yourself an Apple ID and log into that in Xcode. I will show you in a second how that works. And yeah, this gives you a few more benefits like deploying on your device and so on, but it's not 100% necessary, but it doesn't hurt. Okay, Xcode, an introduction. So that's the UI, that's how it looks. I took those screenshots with the previous version, 12.4. The latest is already 12.5, but nothing really changed. So at least in this regard, nothing changed. Yeah, so this is when you open Xcode, this is the first screen you will see. You can create, you see on the right side, you see your already created projects. And you can quick open them. And here you can actually create a new project, clone an existing project from a Git repository, and open a new project or file. Once you click create a new Xcode project, because that's the thing that we will do most of the time, other than opening existing projects, of course, you will see this screen. You can then choose a template for your app. There are multiple ones, and they're actually quite different and quite few. What we will use is the app template, and that's pretty much it. So there's also templates for creating libraries and so on, but we will not go into detail in that course because that would be too much. So for now, we create an app. When you create an app, it will ask you a few things. It will ask you the product name, it will ask you the team. That's where also the Apple ID again comes into play. The organization identifier, which is usually your website domain reversed. I don't have a website, so I just used com and my last name. Then there's the interface, and you might be aware that there is actually something different than UIKit as well out there, namely SwiftUI. So you need to change this here to storyboards and the lifecycle to UIKit app delegate. I hope that we can still do a bit of an introduction to SwiftUI, but now we will really focus on UIKit, because if you really want to work on iOS apps, you will very likely have to know your way around UIKit, and that's the thing that we want to teach you mainly. And language, of course, Swift. Then it will create a template, and the template will look somewhat like this. We will get into detail on all the file types then in the UIKit slide deck. But for now, just to talk about Xcode, on the left is the project navigator. The breakpoint gather, you can actually add breakpoints in here. So if you click there, the execution will stop there, and you can inspect variables and so on in the debug area. Then the code editor, yeah, pretty obvious. There's the jump bar. I will show you in a second what this actually is. and the inspector, where you can, for example, change target membership if you have tests, or do other things with the file, encoding and so on. You will not use this that often, other than for tests. Then a bit of a detailed look inside the debug menu. I will not go into too much detail on all those buttons here. You can look at that then yourself, and I guess this is too detailed for now because we just started with Xcode, but I just wanted to have this here also as a reference for you for later. In the end, when you go back here, this is in the end the view that we see in the next slide, the one down here. And this button allows you to activate and deactivate breakpoints, the controlling of the execution flow. So just continue to the next breakpoint, step in, or step over, actually step in and step out if you go into methods or you want to get back out of them. Then those two actually are pretty nice. They can be the view hierarchy debugger can be used to, as the name might suggest, debug view hierarchies, and it's pretty advanced. And the same goes for the memory graph. So going back to the Swift slide set, if you think about memory leaks, this debugger can actually help you to resolve them because it will show you the cycles that you have. Yeah, and this is just your app, the thread it stops on, and the method. And here you have variables, and you can then, by using, for example, the command P, you can access variables, and it will show you the properties that are set. Yes. Then there are a lot of shortcuts to actually use in Xcode that will increase your speed when working by a lot. You can take some time today as well in the end to look at the cheat sheet if you want. It's also just like I left a link here where I got this from. So for example, like one that I use all the time is Command-Shift-O because that's quick open, and you can just jump from file to file without looking at the project navigator that we saw here. But imagine if I'm on the app delegate and I just Command-Shift-O, it will open a small window. I type view controller, press enter, and I'm switched to the file. Yeah, it's just like all IDEs have things like this. So, and I won't go over all of them. Just if you're interested in workflow optimizations, check out the shortcuts because it really helps knowing a few of them. Yes. Okay, then we will create our first app project. Come on, let me just remove this. So Xcode, I will just click here to create a new project. I keep the app target selected. As you can see here, there's also like frameworks and so on, and we can create games, but we will not do that for now. We will just stick with the app. And then there's a product name, and I will just choose first app now to stick with the name on the slides. And as you can see here, we could potentially switch to Swift UI, but we will stick with Storyboard. And UIKit app delegate is anyways fixed if you chose the Storyboard. We won't include core data or tests for now. This will come a bit later then. So for now, we just press next. It will ask us where we want to put it, and we just put it on the desktop. And we have our first app created. On this screen, the project tab, actually, if you want to call it that way, it's just so if you click here on your actual project, you will see like different information about your project, the device orientations that are supported that you can change. You can actually say, I don't want to support iPads. You can add capabilities, like just for example now, you can, for example, add background modes, or I can't add, usually you should be able to add purchases here as well. But it seems I don't have the capability to do that right now. Yeah, so you can do all kinds of stuff here, but in the beginning, this will not be too interesting for us because, yeah, build phases and so on goes too detailed for the status we're currently at. So let's look at the view controller and the way our code is structured. So as I explained already, on the left we have the project navigator. On the right we have this, how is it called properly? I don't remember, the inspector. And here it allows us to actually, usually you just have this open, the identity and type, and you can see the path and the target membership, but you will not do too much with that. And down here you can see also the debugger, and like that's your first view. And up here, that's the jump bar. You can actually see all the methods that are defined in your current class. So, for example, if I add here hello world, then this will also show up here. That's helpful if you just want to look for a method in a bigger class. You can just open this and type hello, then you move to it. Same goes for one of my favorite commands, Command-Shift-O. I can just type, okay, just to confirm, can you see the overlay that's open right now?
Yes.
Okay, that's good. Sometimes that doesn't work, thank you. You can just type, and it will also add completions here. So you can just go there, and it makes navigating way faster if you know where you want to go. Okay. That's the first project. Any questions to that so far?
Can you maybe tell us what's the best way to combine, like if you use storyboards, but also you code? Like to combine those two?
We will have some more UI. So the next slide set fully focuses on UIKit, and then
Okay.
I will show you storyboards and also how to add constraints in code. But yeah, it's combining those two is always a bit of a tricky one. I can already spoiler that.
Yeah, I found out.
So I maybe to let you know how we do it at my job. We have the older code uses storyboards, but all the new stuff we do, we usually write in code. There's an easy reason for that. At least for us, we are a pretty big team, and as we will see then in the next slide set, merge conflicts are interesting, and also if you mix them, it also gets messy fast. But storyboards are quite nice if you I don't want to say if you begin, because they're also nice afterwards, because it's this visualization that's pretty cool. For those who don't know what storyboards are, it's just like a visual representation of the screen you build, and you can just drag in labels and so on and place them. So it's pretty neat because you directly see how it looks, but it obviously also has a few drawbacks. Yeah, but to answer your question, it's tricky. If you have a concrete example, I can definitely help out later on if you want me to have a look.
Okay. Yeah, I guess I would have one.
Yeah. Maybe we can finish this slide set.
Yeah, after when there is time. Yeah, of course.
Yeah, sure. I plan to have a bit of time in the end for you to start with the exercise, and we can then have a quick look at your example as well.
All right. Thank you.
Sure. Yeah, but as we will dive deeper into this, I won't go into more detail for now. Yeah, exactly. Then simulators. It's a pretty cool thing. They got way better in the last few Xcode versions. Here you can see again this top line in the project, and in here you have, I mean, those two buttons are pretty self-explanatory. The scheme is actually just, in this case, we only have the app target, but if you, for example, have a test target and so on, you could switch between those schemes here. For now, we don't do that. We just keep the app target. And actually, there's also like a whole bunch of simulators that you can run your app on. So I don't know. I really don't want to run my app on an iPod Touch because, yeah, I don't know. I don't like it. I really want to run it on the fastest device right now. I really want to run it on iPhone 12 Pro Max, and that I can choose in here. And this is just like this bar up here just shows you, okay, the latest build status. So as you can see, when I press Command B, it builds the app and it will just show me, okay, the build succeeded. It took way less than a second, and there's one warning because there are no constraints. So, but yeah, we will get to that later. And if I have any errors or warnings, they will be shown here. You saw that. Open library and so on. This is mainly used for storyboards so that we can, throw in different UI types or views. And then we have this show and hide areas, but this actually doesn't exist anymore. That's outdated, but I didn't find a new screenshot. Maybe a spoiler, Apple documentation is not always the most up-to-date. UIKit documentation is pretty good, but especially Swift UI documentation lacks quite a bit of info. But yeah, it's not that important for now. Then I can just show you how it looks when I run this on the simulator. So I just click run here, and it will then load the simulator. This takes some time. Nice, it failed to open. That's great. So now it's open. Now we do it again. And now we see, oh, okay, it's here. And obviously our app is pretty empty. So there's not really too much that's going to happen. And actually you can interact with the simulator as you would do the label. Yeah, true. We added the label to the storyboard, so it will also be visible. But you can interact with the simulator the same as you would do with your phone. Limitations apply. There is no notification center. Notifications are there, but you can't send push notifications to simulator, for example. Yeah, but you can still like do those drags and so on, and click around and open it again. Yeah.
Just got a question.
Sure.
Do I have like to build it every time I change something on the view, or is there like, if I do like just a quick fix to like load it faster?
So load it faster, yes. So there's a big difference between a clean build and an incremental build. Also,
yeah, but the second one still takes some time.
Yeah, so there's, I think Android introduced this once, this live update in Android Studio, but that's not working on iOS. Let's imagine you have this label here and your designer says you need to make it a different color. You need to rebuild the app.
Okay.
Yeah. So it will be faster than the first time, obviously, but it will still take some time.
Yeah. Okay. Thank you.
Sure. And also depending on the class you changed, there is some dependency tree in the background, and it will then need to rebuild all of those classes in that tree. And yeah, build times are not an issue now for the projects we do. it gets a problem for bigger projects, but that's in every IDE. There's no golden solution for that, unfortunately. Yes, running in the simulator. And now we have, again, this. I already showed you this. If you have a real device connected, I can just connect my test device from work. Then I can show you how this looks. So if I go back now, I can theoretically choose the phone firmware and testing that I have. But I didn't update the OS version very recently, so I can't actually deploy on that. Yeah, then you can choose obviously simulators. You can download additional simulators. I don't know if you want to test something on a different operating system version. You can download simulators with older iOS versions, for example. Xcode 12.4 ships with iOS 14.5. No, 12.5 ships with iOS 14.5, obviously. But for example, if you want to have an additional simulator for, I don't know, iOS 12.4, you can, in theory, add this as well. Or download even more runtimes. So you can even download an iOS 11 runtime if you really want. That's quite handy if you have weird bugs that, for example, are only happening on some iOS version, on a specific one. Yes, so there are phone simulators, there are watch simulators, there are TV simulators. Yeah, exactly. And you can obviously also deploy on all of that with the real device. So you can deploy on a real device as well for all of those. Simulator capabilities. Yeah, swipe gestures, I already told you, it works. You can hold the Option key to actually do multi-touch gestures. You can actually interact with the physical buttons as well. So you can up and down the volume. You can lock the screen. There's helpers additionally to create screenshots, the home button, and also you can rotate the device. I can show you that real quick. So in the end here, you can, for example, take a screenshot. It will then just put it here and you can do whatever you want with it. I don't need it now, so I just discard it. Oh, I threw it in the photo app, it seems. You can also use the home button if you don't like the swipe up gesture, because it takes some getting used to on the phone to get it right. And you can also rotate it. Yes. Important thing is simulators are great for prototyping, and just to say this for the whole duration of our lecture, if you don't have a phone, you don't need to get one from Hagenberg, for example. You don't need to get one to try your apps on that. It's fine to use the simulator, but there are certain limitations, and if you ever want to publish an app on the App Store, please test it on a device, because there are some limitations. The simulator runs on the max hardware, so memory and CPU are way faster than on the phone. So obviously the last few generations of iPhones don't really have slow CPUs, so usually it's not a problem, but be careful about that. There are some display differences, like the way the screen is rendered. There are obviously hardware differences. For example, the simulator obviously doesn't have a barometer, it doesn't have Bluetooth, you can't access the camera, motion sensors are not there, and also the proximity sensors are not available. And for example, API differences, ARKit, HomeKit, Media Player, those are all not usable on the simulator. And push notifications, I mentioned that. I linked a web page there that explains this in more detail. But yeah, so just so you're aware that there are limitations. They will most likely not hit us that hard. But if, for example, you want to use the camera in your project, you will need a device to do that. And then, sorry, are there any questions to that? Sounds good. Then dependency management. What are dependencies? So imagine you want to use a fancy UI component that you've seen, I don't know, random example, you saw somebody share it on Twitter or on Reddit or whatever, and you thought, oh wow, that's cool, I really want to add this to my app as well. The thing is, you don't want to copy the code over because that's messy and ugly. And what if they change something on their product and make it even fancier? Then you need to copy everything over again and might mess it up. So what do? You use a dependency manager. And this dependency manager allows you to integrate your own or third-party libraries into your project. And it will resolve dependencies between those libraries. So imagine you have a networking library that you use because it's just nicer to use than the stuff iOS provides. And you have another library that does image loading for you. And this image loading library has a dependency on the networking library. The dependency manager will take care of you for that, and you don't need to worry about it. And it will choose the correct versions that are applicable. Any questions to what a dependency is? Okay, sounds good. By now, there's a few choices to use on the iOS platform. There's Apple's tool, the Swift Package Manager. Then there's CocoaPods, which is, yeah, I'll get into more detail later on. There's CocoaPods, there's Carthage, and I already mentioned the not recommended solution, the copying the code by hand. Let's start with the Swift Package Manager. It's a tool provided by Apple. It's supposedly shipped with Swift 3.0, so already a few years ago, but there were quite some downsides and restrictions and bugs. But since Xcode 11, it's actually pretty good and working very, very well. And it's also open source. And it's really cool. So yeah, but personal opinion. It consists of a few basic concepts, modules, packages, and products. It's not too important. It's pretty much namespaces. The package contains the actual Swift files, and the product is actually the thing that is linked to your app and that the app talks to. But I'll explain that more when we get to the example. And there's a link if you want to read up more on that. Adding Swift dependencies is pretty simple. And there's libraries by now for nearly everything. So networking, database, animations, UI components, you name it. I just added one example here, LMOFire. That's a pretty well-known networking library. And if you say, yeah, I don't want to use the stuff that iOS provides, I want to use LMOFire, then you can just integrate this via Swift Package Manager. How did you do that? You go to, so you open Xcode. I will just show you. I will just move over here. You just go to File. You open Swift Packages. You open Swift Packages and you say Add New Package Dependency. And then it's up to you to add a new package repository URL. And how do you get that? So you can just Google for it, obviously, but there's also something like the Swift package index, which shows you a lot of packages that are available. And I can just type here LMOfire, for example. Then I see, oh, okay, here's LMOfire, an elegant HTTP networking in Swift. I can go here and just copy the link, switch back to my Xcode, paste it, press next. This will take some time then. Then Swift or Xcode actually asks me about the version, and usually you will just say, yeah, okay, I want an up to next version, because usually, so up to next is usually the one you want, because usually minor changes don't include breaking changes, but sometimes it also happens that you maybe want exact versions or ranges between some versions. And if you, for example, want to experiment with some other branch, you can even name the branch name from the Git repository. So if we switch back here and go to GitHub, there are 10 branches, and we could even try out the Linux support, for example. But we'll stick with the version for now and just say up to next and press next. Then it downloads the package. This will take some time. Oh, this really takes some time. Okay, let's switch back to the slides for now. Exactly, and there's like a lot of them, and yeah, you can find all those, and it's pretty easy to use. Oh, there it is. Then we have it here, and we will just add the product to the first app target, press finish. And then we see this also in our project, that there is actually a package. And we also see it here in the navigator that there is a Swift package dependency, namely LMOfire. You can see there's a README even that explains you how to actually use it. There's the source code. And in the end, it's very easy now to use it. The name of the package is LMOfire. So you can just go here and say import LMOfire, which will refer to this library. And then you can say LMOfire dot whatever. So that's how you add a dependency in the Swift package manager. Oh, I already did all that, obviously. Exactly, branches and commits are useful for experimenting. Then Xcode will download the dependency. You can see it in the navigator. And then you can import it in the file that you want to use it in by just using the import statement and import the framework. Any questions to SPM? Sounds good. Then CocoaPods, also open source. That's been available for 10 years already. Wow. It uses a so-called pod file and command line commands to install and update dependencies. And in order to show you this, we will do a quick excursion into the command line. Because I'm not sure that this was part of your curriculum already, or that you're all familiar with that. So with the command line, sorry?
Yeah, we are already familiar with it in computer systems.
Awesome.
Semester.
Awesome, then we can do this very fast. Thank you. So yeah, on macOS, I personally like to use iTerm2 because it's a very fancy replacement for the existing terminal, And also C shell makes the usage a bit easier, but yeah, that's personal preference. And yeah, cheat sheet, as you already worked with it, I will skip this. And then there's CocoaPods. So in order to use CocoaPods, you will need to install the CocoaPods gem. And then in your pod folder, run pod init. What this does, it creates the pod file. And in this pod file, similar to the way we now added a Swift package manager dependency, we can also add CocoaPods in there. And usually you refer to frameworks that you added in a pod file to as pods. So I will probably mix this up a bit because we use this heavily at work. Yeah, so for example, you run sudo gem install CocoaPods, then you run pod init. I can show you how this looks now in the first project that we have. I just need to navigate, desktop, and this is called first app. As you can see, there's only this project in here, and then I say pod init. This will take some time. And to be on the safe side, I will just close Xcode because this can mess up some stuff as well. If I run now, ls, again, you can see that there's also the pod file in there. Why does my auto-completion not work? Sorry. Open it manually. So if I open the project now again, I can still see, okay, there's this with package dependency. And then what you usually will do if you use CocoaPods, you will say add files, and you will add the pod file to the project because you will have easier access than to change things. And what you might also want to do is change the type to Ruby because it's actually written in Ruby syntax. So you get proper highlighting. Maybe to use the same example now, again, as with before. No, I don't have it listed for some reason. I don't have this in here, but there's the web page of CocoaPods, which you can just open. And on here, that's very similar to the things we saw for this with package index. In here, there's also some starting guides, how to create a pod, but that's not that interesting for now. We can just search here for LMO Fire, for example. Then we see some documentation and everything, and we can then just say installation guide, and we can just copy this. That's usually the fastest way to do that. Copy it over, put it in the pod file, and then this is pretty important. We run pod install in the command line, and if you run pod install for the first time, close the project because this will have impact. So pod install will have some impact on your project because the first pod install will actually create a different file for you to work with, an XC. So usually, if you have a look at this, usually, I don't know if you can see it very good, but usually you have this Xcode project that you will work with. But if you use CocoaPods, you need to work with the Xcode workspace. So instead of opening the project, you will now need to open the workspace. This is a drawback from the CocoaPod solution because they actually do quite some changes to your project configuration in the background that you actually don't see that much. But yeah, they do a lot of stuff there. And now it still doesn't work very good. I will just do it like this. So now now you see there's two files here, the first app Xcode project and the XC workspace, and I open the workspace. And from a development perspective, you will not see any difference. Sorry, I need to open it again because it shows the wrong Xcode version. Very good, very good. Come on. So now here we have our first app, and in here you can also see the pods. Obviously, this setup now is everything other than optimal, because we actually have the LMOfire imported in the package manager and in the pods, as you can see here. So don't do that. Also, as far as you can prevent it, don't mix the two approaches. Choose your package manager and then stick with it. I would recommend. Yeah, so that's how you can do that. And I will just, in order so you have this as well, I will just share this in the channel.
I have a question about Swift Package Manager.
Sure.
Does it also have a command line tool, or only the GUI tool?
Unfortunately, only a GUI tool.
Okay. And does Xcode have an integrated terminal, or do you always have to open an external?
You have to have an external, unfortunately. It's, yeah, I know what you mean. It's a bit of an annoyance, but unfortunately that's what we have to deal with. Sorry for the bad news. Okay, then there's one more, namely Carthage. I will not go into too much detail about this one, but it's also open source, and the thing it does differently is that it compiles dependencies into binaries, which means if we check again our code here, what we can do here, we can actually look at the source code of LMOfire. We can debug it even if we think there might be something wrong with LMOfire. And this is something that you can't do with Carthage, because Carthage will only provide the framework as a binary. So the only thing you will see are the public and open methods. Everything else will be hidden from you. And even the public and open methods, you will only see the method declaration, nothing more. This is a drawback and something good in both ways, because the way Swift Package Manager and CocoaPods do it, it will load the whole source code, therefore increasing the build time. And this does not happen when you just import the framework as a file, because you don't need to compile this. This is already compiled, so you don't need to rebuild this. So this is a bit of a, yeah, good and bad thingy. This can be installed via Homebrew. I linked Homebrew in there if you haven't installed it. And it works very similar to the pod file, but this uses a cart file. And due to this pre-compiling into existing frameworks, the updates and installs will take significantly longer. But obviously, the build time is then lower in the end. The setup is pretty much the same. It's a bit more complicated, but for the course, I would recommend you to use CocoaPods or Swift Package Manager, depending on your preference. Yeah, Xcode tips. There's tons of websites on that, how to increase your work, how to make your workflow better, how to whatever. Just have a look at the link, check it out. Yeah, there's a lot of things. A lot of, I mean, we talked about keyboard shortcuts and so on. So, yeah. That's it for the third slide deck, rather short one. Any questions? It sounds like a no. Okay. Then I would suggest a very quick 5-minute break, and then we start with UIKit for half an hour, and then you get time to work on the assignment. How does that sound?
Sounds good.
Okay, sounds good.
55. See you then. Okay. I just enabled the download for the UIKit slide set in the e-learning. So if you want to download it, it should be possible. And on that note, I think we can dive right in. Oops. So UIKit, what is UIKit? It provides APIs to build user interfaces on a very shallow note, and also it provides event handling. So touches, multi-touch. In addition to that, there's animation support, documents, which we will not look at, but still it can handle them, drawing and printing. It holds information about the current device. So for example, is the current device that I'm running on an iPad, is it an iPhone? Things like that. And text management and display. Let me just set a timer. It's until 17:05, is it? I think so.
Yep.
Okay, then let's do half an hour. Sorry for the interruption. So, okay, so UIKit, and now in general, iOS applications. iOS applications are expected to support a key set of features. For example, specific resources and configuration data. Like, for example, you will not see an app on the App Store without an app icon. Just an example. The iOS apps, or in general, iOS apps follow a very specific and well-defined execution path. So there are certain states that an app can be in, like on a very general basis, so not on a use case specific basis, but every app has those states, like terminated, launched, it's in the background sleeping, and so on. And obviously it can transition between those states. And with the transition between those states, expectations change. What does that mean? An app can pretty much do everything in the foreground, work, to do some work, show things, processing, and so on. But as soon as the app transitions into the background, processing time and capabilities will be very limited. And yeah, so this is something that you need to be aware of in order to actually work with it. Exactly. So the app must run efficiently in a multitasking environment. And there are some things, for example, like memory warnings that you need to take in consideration to see, yeah, okay, I minimize the battery usage, I keep processing power low or as low as possible. Yeah. And one thing that's also pretty important is iOS apps are sandboxed. So what does sandboxed mean? Imagine an app. So sandbox kind of means that it lives inside a container, that it has only very limited and small gaps that it can interact with the outside. This is mainly to protect the app from being exposed, or that user data is stolen and so on. But this also then has the limitation that it can only interact with other apps in a limited way. There are APIs to do this. We're not going into too much detail on that, but yeah, it's possible, but very, very limited. Maybe to add here, if you build multiple apps with the same developer identity, then it's easier, just as a side note. How is an iOS app structured? So on very basic terms, it's usually the model. So we're talking MVC here, model view controller in this case. And in this case, the model, like in here it says documents. We will not work with documents because this is not the usual use case that we have. The model can be any user data structure. So it can be a to-do item, anything. Then we have the controller, which involves quite a bit of logic and so on. So the application delegate, we will get into more detail on what this is very soon. Yeah, on the next slide actually. And we also have the event loop. I think I mentioned that already very quickly. This is pretty much the thing that is responsible for passing around actions. So if a user presses on it, the event loop actually registers this and passes it to the corresponding view controller that then catches the interaction and says, okay, do we need to do something? And then there's the UI window. The window is the view that holds all the other views. So it's the base layer of user interface that is the container for everything else that you put in there. But more detail on that on the next slides. We have the UI application. This is only running once. It follows the singleton design pattern, so it has a shared instance. It's only instantiated once. I already said that. And it's the central point of control and coordination. So nearly all state transitions and so on that the app can go into and that can happen go through the UI application. It's also responsible for event dispatching via the run loop. And it informs the app about runtime events. Yeah, low memory warnings, I mentioned that. And for example, the launch and the termination. And usually you will very rarely subclass this. So there's there are not too many use cases to do this, let's say it like that. But you will use the delegation. And we saw this already in our first app example, the UI application delegate. If we look here again, let me scroll up. In here, we have the UI application delegate. And that's why we get all those functions. And this is only like a very small subset of the functions that you can have in there. So this defines quite a few. The app delegate, as we saw it now again, is the core of the application. So it's used by the application, by the UI application itself, to communicate and handle all the state transitions that can go into the app. So backgrounding and foregrounding. So you swipe up to or press the home button to put the app into the background. Then the application delegate. The application delegate will get notified on that, and the same if you open it again, it will also get notified. You can also get notified on termination, and maybe not playing into the state transition, but also if you get a push message, you will receive a notification there, or not a notification, but a method is called in the delegate. And what usually happens in this app delegate is that you set up your initial data structures. So I don't know, you set up your database, you set up your networking controller, I don't know, for example, usually when you integrate some third-party libraries, you do the setup in there and you start loading your data. So there are a few callbacks that allow to do that, and they are mentioned here. So those are the state transitions. As you can see, the top one is called did finish launching with options. And this is your entry point to do customization. So set up your database layer, set up your network layer, whatever you want to do in there. Then we have the Then we have the will resign active, which means go into the background, or it will go into the background. And in addition to that, we also have did enter the background. So there's 2 steps. And same actually goes for will enter foreground and did become active. So this is called first, and then this is called, and application will terminate is called when the user kills the app. Yes, this is a bit more visualized. When you start the app, it's actually unattached. So you press to start the app, then it transitions into foreground active. Then it's foreground inactive, sorry. Then it shows a launch screen. Then once you're ready to show the app UI, this happens when you return from did finish launching with options. Then you're foreground active. If you then don't do anything, it can go into foreground inactive. You can put it into background. And actually, when you have the app in the background for a long time, the system can actually decide to kill it, which means it would be suspended. Yeah, with iOS 13 and also the dawn of SwiftUI, there was a new thingy introduced, a new delegate, namely the UI scene delegate. And this is responsible for handling scene-based app lifecycles, so SwiftUI in the end. Even though this is mainly used for SwiftUI, you will still see it in your UIKit application. But, and as you can see, it has similar methods than as the app delegate. But we will very possibly not touch this at all. If we get the chance to talk about SwiftUI, we will. But with UIKit, this is, so if you choose UIKit project, it will still be created, but your main access point will be the app delegate still. Yes, so we will not use the scene delegate a lot. This slide is just here so you know what this class is actually for, but it doesn't involve UIKit a lot. It's more for SwiftUI applications. Yeah, and same principle, don't instantiate this, rather use the provided delegate that's instantiated. So, and here we have the example I already showed you. There's even a bit of documentation in there, but it's not too important for us now. Yes. Okay. So as we saw before in, I don't have it in, yeah, okay. So as we saw it before in this model view controller example, we saw that the big part of this, and let me switch to the next slide, is the model. I already told you that we will not use documents in this course. It's just that this was the screenshot that Apple provided in the documentation, and I really like the visualization. In the end, our model can anything that is domain specific to the app. In the end, there's differences in the structure that your model will have depending on if you create a to-do list app or if you create a banking app. So which data do you need to store? What do you need to present to the user? What techniques do you use to store the model? So this depends highly on your app or domain specific use case. But don't think too much about documents, because we will not show this. We will not cover this in the course. In the end, it's a way to group data, and you can read and write to a document, but we will not cover this in this course. Here we have it properly again. I don't know why I didn't add it to the other slide. I talked about the UI window shortly. In the end, it's like a presentation of one or more views on the screen. And you usually only have one UI window. I don't know if you, the only use case that I can think of right now where you would have multiple windows would be if you, for example, have a multi-screen app that can also like show a second additional screen on maybe an Apple TV or any AirPlay ready device. So this might be a use case, but if you only have an app, you will only have one UI window. And the view controllers, they are actually view containers that are used to change what is presented on the window. So the window won't change, but only the stuff that is presented on the window will change. And as you can see on the diagram as well, it works together with the UI application and its delegate. There's a typo, to deliver events to views and view controllers. So as you can see on here, the UI application delegate, let's say we have a button on our screen that says, I don't know, touch me or tap me, then the event loop will catch that event. It will, or the UI application will then talk to the delegate. The delegate will forward this to the UI window. The window will forward it to the view, and the view will forward it to the view controller it's contained in. Okay. Yes. So view controllers. Now I lost my red thread. Yeah, okay, view controllers. They manage the presentation of apps content. So just as an example, in here again, we have our storyboard. This is a view controller. It can have multiple sub views. So a view controller consists out of a base view, of a content view that then contains all the other additional views that are on there. For example, a label, a button, a switch, whatever you want to put on there. And you can also have your custom views presented in there. So there's not really any limit to that. And in code, it would look similar to that. So you would extend or inherit from actually UI view controller, and then you get the capabilities to actually present something on the screen, hold on to the super view of your view controller, or of the view of your view controller, and also of the other views that are contained in that view. So it manages a single view. I mentioned this, and its subviews that can be defined by you. And when being presented, the view controller makes those views, and so its view and those subviews visible by installing them in the apps window. And it provides the default functionality for loading and presenting views. And it also, for example, handles the color of the status bar of the phone. So for example, if you want the dark color here, because your screen is so brightly colored, just use this as an example, you can actually change this here. Yeah, and rotation as well. So there are some overloads that you can check that rotation happens. And what's also very important, there are quite some view controller APIs from the Foundation and UIKit, or actually only UIKit, sorry, that provide image pickers, tab bars, navigations, and so on. We will see a few examples of that. And I showed you already, this is kind of what a view controller looks like in a very simple example. Yeah, are there any questions so far? Okay, sounds good. Okay, we have 10 minutes. Yeah, okay, let's start that. Okay, now, so we talked about view controllers. So we talked about the UI window. We talked about the layer above it. We talked about the view controller. And now we're talking about the layer on top of that again. So we're talking about views, controls, and layers. Yeah, views are, in the easiest way to describe them, visual representation of content. And in the end, a view, a button, or whatever, just draws the content in a designated rectangle. That's pretty much all it does. And it also can respond to events inside that area. For example, a button knows when it is tapped. Or a button can respond to the case that it is tapped, actually. Controls are a specialized type of views because they are like pre-built already. So things like labels, so unchangeable texts or text fields or buttons, like you can see it in the example on the right, are controls. And yeah, they are already provided by the system, so you don't need to build them again. Yeah, and it also, the UI kit provides also a lot of standard views. Like it provides an image view if you want to display an image. It provides a UI label if you want to display some text. It provides a text view if you want to have a user enter some text, and so on. What if you want to create your own view that might contain different kinds of views? Subclass UI view. So create your own UI view, and this way you can provide your own custom views. So in the end, you can just write class custom view inherits from UI view, and then you can already add it to your view hierarchy in the view controller and use it in there. So that's pretty straightforward. There's this core animation layers I've used intensively behind the scenes. Yeah, this is a bit cut off, I'm sorry, so it should be behind the scenes. This is also not something that you need to think about much now, because we will talk about animations later. But just so you know, this core animation, so layers, they can be used to do quite complex animations, but we will talk about that a bit later. Easy things first. Okay, let's start with this still. So we talked about very basic iOS app states and what the window and so on are. And now we will talk a bit about the run loop. So let's go back a bit so you can see the event loop. And now we will talk about the run loop. So it is in the end the same thing. It's initiated by the application on launch time. And this is the thing that is responsible to process all user-related events. So like I said before, if you touch the screen, this is what will take this event and forward it through the whole chain in order to land on the view controller and then do some stuff in code. It is executed on the main thread, and we already talked about serial execution. So it will guarantee the execution of events in the order that they are received, because it will do one after the other until it's done. Yeah. So events. The OS will generate events based on user interactions. So as you can see here, for example, a tap. Those are then delivered on the event queue. And as the main run loop is a serial queue, it will then receive them one by one from the event queue and then forward them to the application to the application object. So the application receives the events first, then it decides what needs to happen. So touch events are this, like for an example, touch events are dispatched to the main window, and on there then certain actions are performed. And the output then is referred back or transferred back to the screen, also via the operating system. So update, like, I don't know, tap a button and update the text. This would be one whole flow here. Yes, we already talked about application states, but here's again a bit of a more detailed graphic on how they can actually move between the states. And a short explanation on the states themselves. So not running is, yeah, pretty obvious. Inactive means it's running in the foreground, but it's actually not receiving events. So if you just have the app open and nothing happens, then this is inactive. But this is only a very brief state. So this happens, for example, when you open the app while the launch screen is active, it would be inactive until did finish launching with options is finished. Then you're active, and yeah, exactly. From active, you can then go back to inactive, and from there on transition to background. This is the kind of transition state between active and suspended, and apps can actually request extra time, so to live longer in the background state. For example, to do audio voice via VoIP, or for example, like we do in our running app, location-based services. So our app, due to the fact that you can't have you can, but you shouldn't have the running app open all the time, you can deactivate your phone screen, put it in your pocket, and the app will still record your GPS data, because we are allowed to run in the background due to our dependency on location-based services. And then there's suspended, which means pretty much dead. Yes. Background. Yeah, I copied that wrongly, I'm sorry. Suspended, yeah, background and not executing code. And yeah, it may be purged anytime. So there's no guarantee that a suspended app actually lives long. It can live for an hour, it can live for a few seconds, depending on the system's, how busy the system is actually. So the OS will decide if it kills the app fully or not. But at a certain point, it will kill it. Yeah, we talked about that already. We saw those. The will finish launching is a not recently added, but like 2 or 3 years ago added. Usually you will do your stuff in did finish launching. Then depending on what you need to do on app state transitions, you can then listen to those other methods. In the end, again, to the app termination, it can be terminated at any time. So the user can at any point decide to kill the app. So there's no thing that prevents the user from just swiping up and kicking the app via the multitasking thingy picker. So this can happen at any time. Also, the system can terminate the app at any time if it's in the background, or it can also crash, but that's not really a use case here. And usually you don't have an option to save user data or perform critical tasks. When does an app get terminated? The user kicks it via multitasking UI. Then there's also the chance that the app is misbehaving or not responding. So one use case would be that you do very heavy lifting on the main thread. You, I don't know, store tons of data in a database, and as database access is I/O, this takes some time, and your app is not responding for 10 seconds. The system will actually say, hey, that's not a great experience. I'll discard this app now. and in the background as well when the system needs to free up memory. And I think this is a good point to end it for now, because this is a bit of a different topic. It's only 1 minute. So what I would suggest now, you can, of course, ask questions if there are any. And otherwise, I would say you can head into the exercise that's already in the e-learning, and try how far you can get. If there are any questions, I'm obviously available. I will not leave before 5 after 5. And yeah, we can also look into the problem that you had, Marco. How does that sound?
Sounds okay. Yeah, that's okay, I think.
Do you have a question, or like?
I'm not sure. I finished the first run where I have to create a custom integer.
Mm-hmm.
And I think I'm not sure how we should operate on the operator overloading. If it should only add the values and subtract the values of the integer, or should it do something else?
I think subtraction and addition is totally fine.
Okay.
If you really wanna, I mean, if you already did the first 2 overloads, multiplying and division are not really that hard anymore. But if you sorry.
Okay, no, I thought we had to do something else also. That's why I asked.
Okay, let me open the where is it? Here. Let me just. Okay, let's just go here. So the question is about this. So in the end, the goal would be that you can just simply write custom integer 1 plus custom integer b, and then you get like a new custom integer. That would be the goal.
Okay, so really you make in your own integer, you take a value, that's your value, and with function with the operator overloading and equatable, you're comparing the 2 values, right? Like normal integer operations and comparison.
For the first one, yes, the comparison, and for the second one, like just normal integer operations, just to show you how you can use operator overload.
Okay, so okay, then I'm finished with the first one.
Okay. Okay. Yeah, then you're fast. But you didn't start with the second yet, I guess.
No, I did it in the first break, but I didn't have enough time to finish the second one.
Nice. So in this case, maybe you can then also, for the second one, write a decrypt function that just takes an encrypted message and decrypts it. That would be cool.
Okay.
So, yeah, maybe we can start, and if you see you're very fast again, which I don't doubt, we can see what we can do additionally, maybe. Or if you want, you can also look ahead in the slide set already, but I'm not sure how much sense this makes. In the end, you can also just play around with Xcode if you have it installed already, and play around a bit with simulators and so on. Try to install a Swift package or use CocoaPods. Then you're already a bit better prepared for next week.
Okay.
That would be my suggestion. And the others can now try the first assignment, and we'll see if there are questions.
Are there any naming conventions for the files?
You mean for the hand-in?
Yeah.
Great question. Didn't think of that beforehand. It's like that's a very good point. Maybe just your identifier. So the I don't know, 2010 something.
Okay.
And just name the zip like that and upload it. That should be
okay. And we can just export as new playground. Is this?
That should work, yeah.
Okay.
So export as new playground, then zip it and upload it. That should do the trick.
Okay. Yeah.
I will add the naming convention to the slide set as well, but good call. I totally forgot that. Okay. Then everything clear so far? Sounds like it. Then dive into the assignment. If you have any questions, obviously I will stay in the call anyways. And yeah, Marco, if you want us to have a look together at the storyboard code thingy, we can quickly jump into a breakout room. I guess that would make sense.
Yeah, sounds great.
Okay. Then yeah, we'll probably be back soonish. Let's see if I can help. How do we do that?
I just hope that I can like share my monitor with the Mac, because with Microsoft Teams it's somehow buggy sometimes.
Yeah, that's true. Microsoft Teams is generally a bit buggy recently on macOS. We can also, if you don't mind, you can also share it in this channel, like, or if you want, we can also hop on a different, like, just us two on a call. But I don't mind if you want to share it here. Depends on how you want to do it, to be honest.
I would prefer if I don't like show my shit code.
then we will be right back, and I will just call you on a different. I need to check how this works actually, because I have no idea. But let's see if I can call you on a different thing, like different call. Okay, that's you, and I can just